That's the first part, and this is for part D. This is for parts A through C. We're going to figure out on this problem how many grams of oxygen were used. This time, we're going to say we know that we used 10.0 grams of sulfur. We want to know how much oxygen did that sulfur use up. So we're going to go from grams of sulfur to moles of sulfur, and then we're going to go from moles of sulfur to moles of oxygen, because we want to know how much it used. And then we're going to go from moles of oxygen to grams of oxygen. So again, just say it again. So we've got grams of sulfur. This is the limiting, so it was all used up. So we want to see how much oxygen it used as it was being used up. So this is our 32.07 in 1 mole. This is from the reaction. Look at the reaction there. 2 sulfurs to 3 oxygen. And then in 1 mole of oxygen, I've got 32.00 grams. I've got 3 sig figs, so that gives me 15.0 grams of oxygen. And I always go ahead and write this word in so I've not lost. So are they asking me how much was used? No. They're asking how much was left over. This step always requires a little extra subtraction. I know how much I had. I had this much. This is how much I had. Now I know how much I used, so I just subtract. And it's 32.0 minus 15.0 gives me, I could totally do this in my head, 17.0 grams of oxygen left over. The reason this matters is that if you're using something that wasn't oxygen, something else, then that was really expensive, then you would definitely want to be able to collect and know how much was left over. Or in the case of oxygen, you want to know, probably you'd convert that into pressure to make sure that your vessel can handle the amount of pressure for the oxygen that was left over. That kind of thing. This is very typical for these problems. You should expect 3 sets of train tracks. You should accept a pair that go to the same thing, and then one that takes one of the amounts and turns it into something else.